So this is the 6th event as we cover the O'Reilly book, Observability Engineering. And we are doing that in a series of webinars that we have called the Author's Cut series. And the idea with the Author's Cut series is that we here, the authors of the book, can unpack several bits of content in the book chapters all at once. And we can do that by giving you all of our takes, unbiased and biased, that we couldn't fit into the book or that ended up on the cutting room floor. And we can show you how some of the concepts in the book are implemented using real world examples. So today's session is titled Actionable Service Level Objectives. We're going to be covering chapters 12 and 13 in the book, both of which are about SLOs. So this session in particular is maybe a little bit more single topic than some of the others in our series to date. But there's a lot of meat and there's a lot of stuff to cover. So we're going to start with a short recap of some of the key points that we've covered in past sessions that will be relevant to today's content because we will build on these concepts. But before we do any of that, let's go ahead and meet today's presenters. If my slides will work. There we go.
As we like to say at Honeycomb, boop.
So hi, I'm George Miranda, head of ecosystem and partnerships at Honeycomb, co-author of our book. You can find me on Twitter at gmiranda23, and we'll go counterclockwise on this slide. So Pierre, I'll hand it to you.
Awesome. My name is Pierre Tessier. I'm the director of the Solution Architects team at Honeycomb. We help our prospects and customers get everything they could get out of Honeycomb. And you can find me as Puck on Twitter as well. Liz, over to you.
Hi, I'm Liz Fung Jones, and I'm a principal developer advocate at Honeycomb. And I previously spent about a decade at Google as a site reliability engineer.
And Liz is also one of the co-authors of our book. And our last co-author, Charity Majors, is having some technical issues this morning. So she is working on resolving those, and I'm hoping that she's going to join our webinar in a few minutes as those get resolved. We will go through a recap of some things that we've covered before we pull her into the conversation anyway. So let's start here. If you haven't joined us in this series before, we are just over halfway through the book. And we've covered a lot of meaty material so far. So I'm not going to recap everything that we've talked about, but there are a few key concepts that we're going to build on today. In episode 1 of this series, Structured Events are the Basis of Observability, we covered that the fundamental building block that is necessary for observability is the arbitrarily wide structured event. So having structured events as the atomic unit of work that you capture in your systems means that you have data that is so granular you can always see what is happening, right? Down to the individual user level. And if you have that level of granularity, then you can build any view of the system that you need in any way that you need to see it. An arbitrarily wide structured event is essentially the same as a very detailed log line that is packed with rich context. And distributed traces, right, are just a series of interconnected context-rich logs, and metrics can be derived by aggregating what happened in each event over a given period of time, right? And you can just calculate a metric out of that. So in an observable system, everything can and must be built on top of wide structured events. And it's essential to have such a granular atomic unit so that your investigations don't hit dead ends, right? You don't slam into a wall of pre-aggregated data that you can't see further into. And where that became evident and the need for that was in episode 4, Debugging with the Core Analysis Loop. And in that episode, we showed the investigative pattern that can be used to analyze those arbitrarily wide structured events in order to detect any causal attributes behind system performance anomalies that you're trying to diagnose, right? We showed why it's necessary to be able to slice and dice your data into any arbitrary view that you need to diagnose any issue. And we showed a methodical way of doing that through a practice known as the core analysis loop. So in that session, we covered the importance of using high dimensionality and high cardinality data. Actually, we've kind of harped on that in pretty much every episode of this series and throughout the book. But in episode 4, we showed how and why that's necessary in practice. And so episode 4 was all about the analysis that is necessary to make the most of your telemetry data. And I'm just going to pause on that for a minute, right? Because often the so-called 3 pillars of observability focus on telemetry data types, right? Logs, metrics, traces. Do you have those 3? Great, you've got observability, right? But 2 things there, right? 1, the distinction between logs, metrics, and traces, completely arbitrary. And 2, the kind of telemetry data that you have is only one small part of the story, right? How you analyze it, how you use that data to understand what is happening in your system, that's what matters, right? That is the most important part of observability. And so throughout the book, we assert that, if there are any so-called pillars of observability, what they should really be is the explorability of your data, high dimensionality data, and high cardinality data, right? And again, what we care about are our outcomes, right? How can we use that data to understand our systems? And how do we get better at managing our systems, right? How do we build faster, more resilient, and more reliable services by using that telemetry data to pull better insights? And that's what brings us to today's episode on service level objectives, right? Or SLOs. So I'm just going to start by saying that SLOs are not specifically an observability concept. In fact, we highly recommend Alex Hidalgo's book, Implementing Service Level Objectives, for a deeper dive into the world of SLOs. However, SLOs are much more effective when driven by observability data. And so that's what today's session is entirely about. So chapter 12 in the book is about defining SLOs and why they're a more actionable model than traditional symptom-based monitoring and alerting. So with that, Liz, you are our resident SLO champion at Honeycomb. So maybe do you want to kind of set the stage for this one and get us started?
Yeah, totally. So one of the funny things that happened when I came to Honeycomb in 2019 was I saw that we, number one, were not using service level objectives as a formal concept within our own engineering team. And secondly, that we were so close to having them available in the product that it was just this nice logical conclusion of, if you're already collecting all of this telemetry data, if you're already collecting information on what requests are happening inside of the system, why not derive your service level objectives from that data rather than from some other source of data? So to briefly recap what a service level objective is, a service level objective basically is a set of criteria for what is a acceptable quality of service and how we measure whether our customers are happy with the transactions that are being processed. And one of the ways that we used to try to get people to measure these was basically to say, let's keep time series and metrics, and let's say, I expect the 95th percentile latency of requests to be stay below 500 milliseconds or something like that. But it turns out that introduces 2 problems. Number one, it's really not granular because either the whole 5-minute window succeeds or fails, and also it's impossible to debug. And that was actually a huge hindrance to people adopting this idea of like, hey, let's be able to actually measure user experience. Let's be able to stop alerting on all of this noise. And therefore, when you put together observability and SLOs, that it really makes your life a lot easier. Because it means that you're using real event data, and also that you are able to effectively figure out, from this population of outlying events of things that are slow or failing your expectations, what's going wrong. So that was the pitch. In basically May of 2019, I went to charity and said 2 things. Like, number one, can we have SLOs can we keep SLOs internally at Honeycomb? And number 2, like, can we build this into our product? Because we are so close. I see Charity's here now. Her video is not on yet, but when Charity's video does get on, I hope that she'll share with you kind of what her reaction was to being asked to add a whole bunch of product surface area.
Hi. Yeah, my laptop still hasn't charged up, so I'm on my phone. It is what it is. Yeah, so when Liz joined, it was weird because I hadn't even thought about doing SLOs at that point. And yeah, adding a lot of product surface area, it was like, okay, we've already got our plans for the next year, which is why, we didn't immediately assign engineers to go do it. Liz and our data scientist went off and prototyped it for a while. But it made sense because there's always been kind of this missing link between how do we get people into Honeycomb, right? What triggers it? What tells them, okay, it's time to go look at and debug your systems now. And the world of paging is ridiculous, right? Like we've all evolved these systems where, we start out with they're small and we just start paging on everything. And then we grow up and it's like, you just swing back and forth between over paging yourselves and under paging yourselves. And it's terrible. And SLOs seem like the right way to get around that, because it aligns the engineer's experience so beautifully with your user's actual experience.
I think the mechanism for that is exactly what Liz described, right? That rather than focusing on, on symptoms that tell you something might be happening, right? Like pegged CPU, you're running out of memory, right? Too many threads that are open. Instead, you are looking at measures of the actual user experience, right? Like in Liz's example, how long is it taking this page to render, right? If it's over 500 milliseconds, that's unacceptable. We're not meeting the kind of experience that we want to promote, right?
And guess what? Your
yes.
users don't give a shit if you're out of memory. They actually don't care.
Yeah, exactly, right? Nobody cares how many threads you have open. And so why do you alert that way, right? Because over time, you've learned that those things are indicative that some problem you may not be aware of is actually happening. Whereas SLOs flip that, right? Instead, focus on that end user experience. And if that is a problem, cool, then it's time to go debug and figure out what's happening. And that actually requires this little bit of a cognitive leap where you have to be certain that once you know an issue is happening, that then you have the right breadcrumb trail to follow to figure out why is that broken? What is happening, right? And I'll tell you, coming from the world of symptom-based alerting, right? In that world, it's common to get, floods of alerts, the kind you're mentioning, right? Just like, 20 different alerts, 30, 40, 50 about the same problem. And vendors now package up, AI solutions that will group those and try to reduce the noise for you. And we've become so accustomed to the fact that we're just going to get these massive streams of alerts to tell us that something's wrong. Why? Why is that normal? Why is that acceptable? Right? Because,
as they say in the Emperor's New Groove, right? Like, why do we even have that lever, right? Why are we just dropping ourselves into the trapdoor of alligators?
Seriously, right? Yeah. And that's exactly what the experience is. And so the idea with SLOs is change it, right? Focus on the thing that matters. Let that alert us. And then it follows. We have to then be able to go and figure out, okay, why is that happening? But that is just such a shift from the way that we do things. I think it often takes organizations a while to
there's a lot of fear.
Come around. Yeah.
There's a lot of fear. I mean, and we all, like, the objection that I hear the most, that I hear echoes of myself in it, is just like, well, but we don't want to page when users are in pain. We want to page before they're in pain. We want to let ourselves know before there's trouble. And that is just such a beautiful dream. But it's not going to happen. It's not going to happen because there's so much noise already in, what your users experience. And to add the element of like precognition to that, it's just impossible. You have to align yourself with what is happening in your organization, not what might happen, what will happen.
I like to talk because, go ahead.
I like to talk to the story of a customer of ours who was under that trigger overload. They had that problem and they moved to SLOs and they were able to actually catch the problem before it was customer impacting. However, their triggers caught as well, just nobody cared about it because it was caught in this flood of triggers. It was like the wolf crying sheep. When the SLO went off, they knew there was a problem that was imminent and they were able to get on top of it before the big morning rush came in and would have probably took them down. So the SLOs are absolutely the way to get around that.
The biggest thing that SLOs do for us, for everyone, that is a great thing, is it cuts down the number of triggers and alerts by an order of magnitude, like consistently. You go from 900 to 90, but those 90 really matter.
I
But
hope not 90, right? Like we advise them like basically somewhere between 1 and 5 SLOs per service that you run, right? Like you're not going to have, when we say 90, we mean 90 organization wide, right? Whole organization, not 90 per service. The other thing I wanted to briefly mention for alignment with the SRE book is when we're talking here about the flood of alerts, those are the potential cause-based alerts where you have to set a trigger on every single potential cause of an outage. And I think we got tripped up on words there because SLOs are actually symptom-based alerting, right? Like that symptom-based alerting is good. Potential cause-based alerting is bad. So symptom alerting means that you're alerting based off of user experience and what symptoms users are seeing, rather than everything that's going floppy in your system.
thank you for that clarification. Yeah, and Charity, I was chuckling as you spoke because I see myself a lot in that comment, right? We want to know before users are experiencing an issue. And I think I would hear that a lot. And I would even echo that sentiment because we're so accustomed to the fact that the troubleshooting and debugging cycle is going to take so long that, by the time we realize something's happening, it's already too late, right? We've already lost so much time. And I think part of the reason that observability and SLOs go so well hand in hand is that you can cut down the amount of time that it takes to identify and triage where issues are happening.
Cut it down, but like be able to rely on it.
Yeah.
It's instead of like this sort of hazy, like, just we're kind of jumping around looking for hypotheses to like you just said earlier, following a trail of breadcrumbs, like one foot in front of the other. Like that you can find the solution. You can find the cause of it every time within seconds if you're using, something like Bubble Up and SLOs.
Yeah. So with that, actually, whoops, I cannot slide today. There we go. One of the things that I thought would be valuable in this session to talk about is in the book, we actually use an example of what it was like for Honeycomb to sort of make the cognitive leap, right, and get over some of the fear and start using SLOs in practice. So I thought maybe we could even like expand a little bit on that story and maybe even hear about what we've seen from other organizations. Like, how do you actually start making that shift and getting over the fear and moving towards a culture of using SLOs?
Feels a lot like the chicken and the egg, right? Like for a long time, right? Like it was like I would dearly like to use SLOs, but I don't understand how I'm going to debug it, right? Like if I just have this alert saying that something is wrong for users, how do I actually figure it out? And the answer to that is observability. But conversely, right, like if you are coming at things and you're saying, hey, how does observability change how I do alerting, right? And you haven't done SLOs, right? So this is why I say so much that, right? Like,
Liz, you said something in there that I just want to pull on that thread real quick because I think it's super important. We have not only become accustomed to like alert flooding ourselves, but that's how we know what's going wrong. We're like, okay, so out of this flood of alerts, I'm getting one from Memcache and I'm getting one from that Ruby instance, and I'm getting one from Redis. Now I know what's wrong, right? And that flood of alerts is literally how we figure out what's wrong. So the idea of taking that away is not just like it's better for our users, it's better for us. It's like, how am I going to be able to debug it? Sorry, over to you.
Yeah, so I think basically trying to adopt one without the other is definitely harder than doing both at the same time. And I think that when it comes to adoption of this idea that people should be able to own their own services, it turns out that SLOs can actually be super motivating. When we talk about production ownership, that that talks about owning the user experience, right? Not just owning, is the service up, but like to own, is the service delivering results for users. So I think that's kind of really powerful for software engineering teams.
There's an interesting comment in the chat about what we were just talking about, right? And the comment is that you can still event, and record that things like that happen, but you don't necessarily need to alarm, right? And I think that is a way to do things. And one of the things that I really appreciated about the story that we have in the book is that, Liz, there was a point in time where Honeycomb was kind of doing the same thing. Right? When we were testing out SLOs, we had our traditional monitoring alerts in place and we had SLOs in place. And I think we kind of wanted to see what was the difference there. Can you talk about like what that experience was like a bit?
All right, 1 second. All right, I did not manage to catch that, George. Sorry. You're saying?
Oh, sorry. In the book, there was a similar experience to with the comment in the chat window, right? Which is that you can event, but you don't necessarily need to alarm. Essentially, when we were trying to capture, like, see how the way that SLOs worked, right? We had both our traditional monitoring and SLOs running at the same time, just to kind of get a side-by-side comparison of what we were understanding. Can you talk a little bit about what that was like?
Yeah. So that was in November of 2019. So at that point, we'd had an SLO feature for about 3 months, but it still wasn't being used for a majority of our production alerts. We were using it as a secondary source of, hey, this might be worth digging into. And what changed the minds of engineers at Honeycomb about the utility of SLOs was having an outage, a partial degradation that was caught by SLOs but not caught by our monitoring, where our monitoring systems were basically looking for two consecutive failed probes in a row. And when you have a 1 or 2% brownout, 2 consecutive probes failing in a row is not likely to happen. Whereas our SLO immediately had started burning. And we are able to figure out relatively quickly that there was impact to users. And that was kind of that tipping point for us of realizing that SLOs are just so much more powerful. That SLOs could really help us understand the nuances of what was going on with users, especially kind of in the long tail, rather than just what's the majority experience.
Yeah, I think that, and I don't think we'll spend too much time here because we do cover it in the book chapter, and I think it's worth a read to see what that was like for us as an organization. But Pierre, as somebody that really speaks to a lot of our customers, I'm curious what you see from other organizations in terms of adopting SLOs, what those patterns are like, and how they learn to make the shift as well.
The adoption always starts off with, we know we want it. We're not sure how it helps us, how to really use them. And a lot of times it's about helping them craft those initial SLOs. We've got tools that we use and we work with our customers to help them understand that. We try to break their services down into different components, different types. But one thing I'd like to call out is 1 SLO per user journey. No more than that. Your SLO should be looking at error and duration, or what really matters, right? If you're at a request response system, that's what matters. If you're something about you're about data persistence backend, then you want to make sure you actually wrote that data to disk and it's good, it's secured and backed up. And your SLO should be based on those kinds of things. But ultimately, you want about 1 SLO per user journey. And once they do that, we'll have them attached to the most impactful user journeys, the ones that matter the most to them, perhaps highest revenue or the ones that are highest value, if you will. And when they go off the one time, they're like, wow, we never knew. That's when it just clicks in for them. And you see that kind of avalanche down into, we're building one for every user journey now. But it always starts with 1 or 2. And very recently now, we've had several of our customers come up to us and say, we've been playing with 2 SLOs. We want more. Can you help us out, Honeycomb? And it's great, really. I want to probably thank the book for that, because people are finally able to read up and really understand how to do them. But we've definitely seen a big uptake in SLO usage at Honeycomb.
Yeah, I remember when we were at Parse and we tried implementing SLOs, and we didn't get very far, and it was just because the tooling wasn't there. We started realizing that we were going to spend 6 months building a tool to do SLOs right, and then we were like, oh shit, well, that's not a great use of our time. But it was really frustrating because it's more complicated than it looks on the surface. On the surface, you're like, oh yeah, oh cool. We'll just like align our alerting with what the users are experiencing, and then you start down the rabbit hole of, okay, but what does that mean? And which users and which requests and which do you exclude and which, and then you have to build a whole fucking product to actually do it well. So it is really good to see that the tooling has begun to really be there for people, because you can't have two jobs, right? Your job can't be, build SLOs for your company and keep your systems up and also build an SLO product.
And fortunately, I know way too many SRE teams that have had to kind of MacGyver SLOs with freaking spreadsheets.
Oh God, wow.
And it still happens today, Liz. We still run into people who cobble together spreadsheets, take daily stats to give themselves SLOs. And the SLOs are less about becoming something actionable and more about reporting for an SLA, which is unfortunate. It's kind of the right attitude. You're starting off, but your SLOs need to be real time. They need to be event-based as well, not slices of time like metrics are.
Yeah, what this reminds me is chapter 13 is another real show your work chapter, and we really get into like the internal guts of calculating error burn budgets and like what some of your options are. But before we get to any of that, it might actually be good at this point to just like pause for a minute and actually look at SLOs and look at what we're talking about to ground us in a little bit more context before we kind of dive into the inner workings of the tooling and how it all comes together. So Pierre, you want to walk us through and maybe show us an example?
You're muted, Pierre.
I'm gonna unclick my mute button. It wouldn't be a day if I didn't hear you're muted here. What we're looking at here is the SLO screen in Honeycomb, the SLO feature, the product that we're talking about. I'm gonna explain some of the screen itself, and I'm gonna get into how this is awesome in the end. So a couple things. The very first chart you see here, this is your error burn down chart. Let's remember SLOs are about burning an error budget. We're going to allow ourselves to be a little tiny bit broken. We're going to allow ourselves to have a couple errors. That's our error budget. We're allowing ourselves to have some bad events that happen. And as we burn through those events, we're going to take away from that budget. So this chart here always goes down because you don't gain budget. Time will give you more budget, but you're always burning it away. If this chart reaches 0, I've got no more budget left. Here, my SLO has a 99.5% target over 7 days. That means when we think about events, and I want everybody to really think about events here, not time, but events. For every 1,000 events, I could have 5 that violate my SLO's definition. And if I were to have 5 for every 1,000, I would hit that exactly, then this chart would read 0. I'd be out of error budget. Probably a lot of triggers going off at that point in time, but that's really what we're trying to get at here and explaining it. Now, I want to pause here because I've mentioned events, and I want to talk a little bit more about events as well. 2 a.m. is not the same thing as 2 p.m. So we need to stop treating those time slices as the same thing. We should not say, hey, if I had a problem at 2 a.m., it's worth just as much as a problem at 2 p.m. No, your event volume is different at those times. And we should be basing our SLOs based on event volume as well. And that's really why it's important to go off events. There's many other reasons as well. You get the granularity with it. You can do the high cardinality exploration on it. But SLOs based on time, good. SLOs based on events, awesome. My SLO definition here, the SLI itself, not too overly complicated. It's saying, hey, for every single trace coming in, for the root, is your duration greater than 1,700 milliseconds? If you are, you're burning down my budget. If you're not, you're okay. Now over on the right,
I think that gets to a question in the chat, which is like, can you combine this with error status? And the answer is yes, you can, right? Like you can require that something be both fast enough and also successful.
We did not code that in here because this is a demo environment and we fail quite a bit and our SLO would look really bad. I'll cover that in a little bit though. And I'll show some much cooler looking definitions. Right here, we've got a couple of these things we're calling exhaustion time alerts. And what these are, this is Honeycomb predicting where your SLO burn is going. So we're going to continuously look at the trend, the most recent trend. And if you give me a 4-hour, a 2-hour, an 8-hour, 24-hour, 48-hour, whatever it is, you can have as many as you want. We'll forecast a trend out. And if the trend will say you're going to go below 0, we'll go ahead and trigger that notification. Here, 24 hours, it's kind of important, but not right now important. That goes in Slack. Somebody wakes up in the morning, you get to it. We don't need to PagerDuty and wake you up at 3 a.m. You can get to it in the morning, get to it, keep your work-life balance in check. 4 hours, that's an emergency. No matter what time it is, PagerDuty, go off, let the persons know, let the on-call team know, we need to fix this now. We have a customer impacting event. And this really helps you just using burn time alerts to keep that kind of that work-life balance in check, and you make on-call suck a lot less. Down below, we get into a heat map with Honeycomb. And if you've used Honeycomb before, we love heat maps. Use heat maps. Heat maps are great when you have raw data. Use heat maps. But we've added a new color to our heat maps. And it's this gold color right here that you see. And this is where Honeycomb creates what I feel like is magic. Honeycomb, all these gold items here, these are the things that violate. Those are the events that violated my SLI. And Honeycomb is going to take every single one of those events, every single attribute in all those spans, and compare them to every single attribute that is not yellow in this chart. And it'll come back and say, what's different? What is unique about your errors, about your SLO failures that stands out from the rest? And this is what makes them actionable. 100% of my errors are the exact same endpoint. Note to self, we're going to filter on that endpoint. We're going to use that endpoint to base our investigation. It's clearly something's up with cart checkout. 100% of the errors error, but only 9% the baseline. These other ones that kind of spread out all over the place. Name, in our case, name and route. We do have more routes per name, but here you can only see one matchup right there. And the same thing with targets. It's all kind of validating that. But we have one more cool little key in all this whole chart. It's user ID. This is that high cardinality data really coming to life. In this platform, we've got just shy of 100,000 unique user IDs. And Honeycomb was able to say one of them, and only one of them, is responsible for 54% of your errors. Maybe like a bot-like thing, but I've learned a lot. I have learned that user ID 20109 is causing me problems on cart checkout. And all I had to do is look at this SLO dashboard, if you will. And I'm going to go on a small tangent here and talk about observability and dashboards. In monitoring, you create a dashboard because a trigger and alert went off and you said, well, I'm going to catch it next time. We're going to make a chart for it. And then you've got 500 charts and 500 triggers. And when something goes off, you have no idea where to look because you're looking at things that happened before and somebody built a chart about. What about the brand new code that got deployed this morning? How are you going to be notified and charted on that? Well, that brand new code, if you follow observability-driven development practices, would have came with attributes and context. And that attribute and context would have flowed up right here in my SLO dashboard if it did cause a problem. This is my observability dashboard. It's an SLO, always morphing and telling me why it's happening. So continue that debugging journey. I'm going to click on this and say, hey, let's filter on that endpoint. And remember user ID? Yeah, let's add a group to user ID right away. And now when I get my view, I can understand what that user is doing and start that debugging journey to really dig in and fix the problem. This is a demo platform. We fail every 4 hours or so. So that's why the charts kind of look like this. It's a demo platform. Of course, the demo is going to look good.
To play devil's advocate for a second, Pierre,
yeah, sure.
Why don't I just set up an alert by user, right? Like, why is it that I can't do this with a regular monitoring tool?
Well, it would be pretty ugly to set up an alert by user that groups on 100,000 unique high cardinality items. This is just our demo platform. We've got customers who've got millions of unique things. So trying to set up an alert that groups on those high cardinality items is going to cause a lot of pain on the alerting platform backend. That's a lot of groups, there's a lot of memory. I don't want to get into query performance with time series platforms, and especially around high cardinality, but you're going to be breaking things at that level. That's my first kind of throwing out there. And it also required you to create an alert for a thing, Liz. How did you know you had to do it for that thing? What if it was, I don't know, people using iPhone iOS 14.1 with a French language pack hitting out of Canada? Are you going to create an alert for all those conditions too?
So I think what we're getting at here is SLOs are not influenced by kind of hindsight bias, right? Like SLOs let you go on this debugging journey no matter where this is coming from, rather than kind of presupposing these are the 5 things that you think are going to break.
Yeah. Grace, I see your question here about different latencies for different URLs. And although you could combine them in one SLO, I want to caution on doing that. Keeping an SLO to a user journey makes more sense. Now, if there's a couple of user journeys that are very closely related and you want to measure them together, yeah, that makes sense to combine both paths with their own kind of conditions in there. But I would caution that you separate your user journeys so you best understand what may be impacting them. This is a demo platform. Of course, the SLOs look good in a demo platform. We're at Honeycomb. And Liz was telling you about how we took some time to transition from triggers to SLOs. And although we don't have 90 SLOs, we've got 30 of them. That's what we need to run Honeycomb. This is our dog food platform that we use to actually run Honeycomb production. There's quite a few SLOs on here. Most of them are in okay state. We've got a couple that are negative and in trouble, but that's okay. I just picked a couple to talk about because they had some impact happen to them. Last week on August 3rd and 4th, we had 2 things that actually transpired. This first one is about people who were using our management API. And you can see here, I've got a bunch of yellow stripes. It actually chewed down quite a bit of error budget and did trigger at that time. What's going on, right? Why is this happening? Luckily, the SLO dashboard told us exactly what was happening. And I got to be careful. I cannot hover each one of these fields here, but look, this is the API key, and it's only 1 bar that's well above the rest. I can hover a team ID, and when I do this, you'll see that 92% of our problems on this SLO was the exact same team ID. The field next to that is team name. It was a brand new customer. They just needed a little bit of CS onboarding, customer success onboarding assistance is what they needed. They were just not doing it right. And we were able to catch this quickly and work with them. So this was happening at 6 a.m. Eastern time, again, all the way until 9 a.m. Well, we got on top of it. We reached out to them and said, hey, we think you're not quite doing it right. We worked with them, and now we have a happy customer. And
What's
you know what
also
doesn't
really
matter?
cool about this,
Yes,
what's
go
also
ahead,
really
Liz.
cool about this is that this is not like, right, like if you look at the rate of burn, that was not something that was going to exhaust our error budget in a matter necessarily of hours. It might exhaust that error budget in a matter of like a day or 2. And therefore that was something that we didn't have to wake someone up in the middle of the night for, but it was something that our customer success team was able to hop right on top of during working hours, which I think is really fantastic.
Exactly that point, right? This triggered the 24-hour burn that went to Slack. So we were able to jump on it in the morning when we logged in, helped them out, took care of the problem, happy customer. This wasn't necessarily an operational issue impacting now, but you know what, Suck? That one customer was not having a great time. And we were able to identify that, work with them, and provide them with the solutions that they needed to be successful. And now they're very happy, been using our platform, got a lot of really nice notes from them about this whole entire incident as a whole. Let's talk about something a little bit more complex. Later on that same day, so not quite at 9 a.m., we did have some other impact. This one here is looking at retriever query errors. Retriever is the service that queries our platform. You can see this is a big drop. This did trigger several of these go off. And we also had another similar one on our trigger SLO. So clearly triggers require retriever to do the query work. So we knew there was something going on, and it was really impactful on us at this time. We did some investigation. Unfortunately, the investigation really gets into a lot of very sensitive information, but I'm just going to kind of highlight a couple of things. It was a specific build that was largely responsible for this. There were some code changes in place, but what they did is they exaggerated certain details associated with some of the customers with specific columns inside of their data sets. And we did have very specific data sets that were called out that chewed up much of this budget. And we were able to use the commonality across these data sets to dig into exactly what was going on. So the journey actually started off with a clicking on here and saying group by field. And then from here, they were able to dig in more, understand the impacted data sets, and our SRE team dig in and say, got it. Make the code changes, deploy the fix, everybody's happy. But that was using SLOs to help that debugging journey and being pulled into SLOs, knowing where to look, because Bubble Up built into SLOs put it all together. I'm going to kind of wrap it up right there. George, I want to make sure we leave some time for people to ask questions and anything else we wanted to present as well. I hope you've all seen and learned a lot about SLOs and how Honeycomb uses SLOs and how they can help other customers. Their power are not just a reporting tool. They really are actionable and allow you to go that next step when something happens. It's not just trigger goes off, look at this dashboard. It's SLO goes off, here's why.
Yeah,
and I think that
really...
nicely.
Go ahead.
And I think that nicely segues to talking a little bit about chapter 13, because we were talking about, like, the rate of burn alerts, right?
Yeah.
And how it's really, really meaningful to look at the slope of that line, right? Rather than just, 1 out of 1 request at Sunday at 2 a.m. failed. Oh my God, right?
I love chapter 13. It is a really dense chapter. And I think along with chapter 16, which is how to build a data store for an observability workload, this one really, really gets into the inner workings of how you how you manage your look ahead window versus the look back window, how far forward you can extrapolate what's going to happen to your burn alert, right? Like, you want to alert well before you've burned through your entire error budget. So what are the right mechanisms? What's the right amount of time to extrapolate forward? How do you manage that window? Is it sliding? Is it fixed? What are the pros and cons? And it really just sort of walks through a lot of the nuance, way more nuance than we have time to cover right now, in terms of, I think one of the mechanisms that we use in this chapter is there is a recurring word problem that basically says, in this amount of time, you had X many requests come in, Y number of requests failed. And so what does this mean for the next 4 hours? What does this mean for the next 24 hours? And we look at basically changes in workload, right? What Pierre was saying earlier, having failures at 2 a.m. is not the same as having failures at 2 p.m., right? If you are missing 1 request out of 1,000, probably not the biggest deal in the world, right? If you are failing 1 request out of 10, much bigger problem. You're going to burn through a lot more of your SLO when your workload is slow, right? When each request is comprising a lot more of that volume. And so in this chapter, we basically look at different ways that your error budget is managed and calculated, and use that to basically look at what happens in high availability systems, right? Especially once you start going above 3 nines. If you are using time series data, right, where you've got good minute versus bad minute, right? If enough requests failed in that minute to call it bad, right? Like 50.1% of requests failed, great, we're going to consider that entire minute a series of failed requests. That means that suddenly, right, 49.9% of requests that were good got bundled into that, right? That counted against your error budget, versus looking at each individual request, did it meet your needs or not, right? And so I would highly recommend diving into the book. You can get it free from the Honeycomb site. If you want to look at examples in very, very concrete ways, both of how those determinations are made in terms of what's going to happen to your error budget and how fast it's going to burn, and some code examples of how that can be calculated, I think the book is a great way to dive deep into those. But I don't know if we want to say anything at a higher summary level than that, Liz.
The only thing I want to say is you do not have to worry about doing the math if you entrust someone, someone who has thought about it a lot, whether it be, me for Honeycomb, or whether it be folks over at Noble 9, right? Like, don't be reinventing this math yourself. Like, it's helpful to understand how it's done, but like, please don't do this yourself.
I think the book is really helpful to lay those things out, right? Just to show the full path, right? The show your work portion of how is this done. If you are so inclined to go down that route, you could, but to Charity's point earlier, right? Trying to rebuild that tooling and reinvent the wheel. Is it the best use of your time? I'd say go back and look at some of the build versus buy arguments that we've had earlier. I see in the chat that there's just a reminder that there is a survey that you can fill out We've covered a lot of really great content here today. And I just want to remind you, if you have questions, please go ahead and add them to the chat. I know that there are a couple in there that we haven't gotten to, so we'll use those for Q&A. But while your questions are coming in, I just want to remind you that we value your feedback and we want to know what you thought about today's content. So if you complete a survey about this webinar before tomorrow at noon Pacific, we'll send you a t-shirt to say thanks. So you can use the link that's in the chat, or you can scan the QR code on your screen. There is a password to fill out the event form. So the password for that is event6, event space 6. So let us know what you think. We'll use that to help inform what we present in future webinars. So we're going to go to Q&A and questions that we have not yet been able to address. Also, I want to let you know that if we aren't able to get to your questions, or if you're watching this on demand and you want to ask questions about any of the content in today's webinar or content in webinars past, you can join us in the Pollinator Slack group in the book club channel, and you can ask your questions there. So with that, let's get to any questions that we still haven't gotten to. There was an earlier question that we sort of touched on, but I think it'd be helpful to get a little more into. The question comes from Daniel, and the question is, are there any tools or operational frameworks that are useful for building discipline around identifying what your SLOs are and moving towards identifying based off of the SLOs instead of potential causes? He's been in alerting hell on Teams, and some things have worked to move us out, but he finds that he doesn't have a lot of resources on standard like discipline tools for setting SLOs. So any frameworks or tools that we would recommend for that?
I think it's two separate problems, right? Like while you are working on the business case for SLOs, to address alerting overload, the main thing to ask are basically 4 questions. This is a framework that's listed, I think, in the monitoring book, in the monitoring and alerting chapter of the Google SRE book. Around, is this actionable? Is it urgent? Is it like is it something that requires human thought, or is it automatable? And is it something that we expect to, is it something that we think that we can actually make a difference in, right? That when you start asking those 4 questions about your alerts, that helps you like trim away most of them, right? Like, if there's no user impact, then it's not actually urgent. Or if it's something that a machine could have done to automatically squash, right, without causing impact to users, then it's not something that requires human judgment. But I think with regards to setting SLOs, right, like those questions naturally lead you towards, okay, so how do we know whether this is something that is impacting users, right? How do we know that this is actually urgent? How would we measure whether it's actually urgent? And then that starts to kind of give you that connection between kind of getting out of your alerting hell and kind of what milestones you need to measure. Kind of how are we actually measuring reliability rather than just kind of lower level potential causes.
Oh, thanks, Liz. There's another question, and I know that we touched on it and we addressed it a bit, but Pierre, I'm going to direct this one at you and see if you can expand on the nuance a little bit. So this was the question around having one SLO per user journey, right? And the question is, would this ideally be one composable SLO, which is errors and latency and availability per journey, or still separate SLOs for each of those aspects? We showed and we talked about how you can make a composite SLO in your SLIs, but you did make a comment around separating out user journeys or some nuances there. So maybe Pierre, can you kind of expand on what you meant?
And I actually want to talk about, it's the same user journey, but maybe classified different based on your users or customers leveraging that journey. We do have some customers that just produce workloads which are not like the rest of them. We still want to know when they're doing something that's not happy, that's causing displeasure. But their thresholds are not necessarily the same as the rest of the population. George, I'm just going to take the screen real fast. I meant to actually share this, but I kind of lined one up right here. And here is one of those SLOs right here. So we've got a couple data set IDs, these 5 right here that you see, 21583, 54804, these 2 in the 60,000 range. These are those problematic kind of data set IDs from customers who do things differently. And we are actually presenting numerous different thresholds based on what they're doing versus the rest. So everybody else has one threshold, and all these other data sets have a different threshold based on their query source. Is the query source normal, or is the query source metrics? Is the query source APM, or is the query source trace? And based on that, we'll give them different thresholds for those data sets. This is the same user journey. We're just looking at it in a more different manner based on the user hitting that journey. So that was one example I wanted to showcase. We have other examples where we actually do math inside of our SLOs, and we say, if the payload is 50 different items, and we're going to allow ourselves 5 milliseconds per item and response code under 400. Those kinds of things are also very typical for us to do a composite, if you will, SLO, where you're measuring two different thresholds, the error rate as well as the latency across that user journey. This one here is a little different, where we're segregating the thresholds based on the kind of user doing that journey. Did that answer? I'm hoping that answers your questions. If not,
so.
Please bring in some pollinators.
Yeah. And if there are follow-up questions, I'd love to see them in chat. For me, I think that's great, because to me, what that illustrates is it's the same user path, right? But based on, or user journey, but based on the execution path, right? And like the nuances of what you are doing in this journey, right? There are ways to qualify that and, set expectations for, the different paths that you can take. There was a follow-up question, Pierre, and you sort of touched on it, right? Like some SLIs where we do math or a little bit more processing. The question is, what are some of the most complex SLOs that we use at Honeycomb? I think this one is fairly complex.
I'm going to say this one here is one of them,
okay,
for sure, because we're taking ththose 5, we're breaking them up in different ways. I like another one here. It's latency per event. This one here is also has a kind of fairly complex one as well. This one does math, and that's why I like its complexity, because we're actually doing some division down here, the number of items in the batch. And ultimately what we're saying is we're going to give ourselves 5 milliseconds per item. We're also putting ourselves against certain status codes. We want to make sure that the status code is really at 200. You can see right here, and status code equals to 200. So this one here, perhaps not as complex because there's less words in it, perhaps more complex because it's combining two things and doing math as part of its evaluation.
I think we have time for one last question, and there's a lot of curiosity around what the conversation was like around segregating SLOs by customer. Right? Did we determine a threshold of difference, or how do we determine we're going to make that sort of I guess, how are we going to arrive at that sort of decision tree, right? That's something that we iterate towards. Like, how does that unfold?
That was iterated towards. Absolutely. And it didn't start with just 5 data sets. There was one data set. We were saying, wow, we have this data set kept on showing up, and it was causing us problems. We were working with a customer, and it wasn't problematic to them. It was problematic.
Right, exactly. It goes to
eyes.
customer expectations, right? Like, why are you over delivering on reliability if the customer is fine with a lower level of reliability, and you would be burning out your team trying to achieve that higher level of reliability, right? Like, it's like, we're not going to burn people's time and energy getting paged at 2 a.m. for query performance of a customer that expects the queries to actually be a little bit slower given their volume of data. Obviously we strive in the long term to bring that down so that all of our customers experience roughly the same amount of performance, but there are situations where sometimes there are factors that require engineering or design changes.
And I just want to point out, right, that sort of segregation and that sort of decision tree is possible because, again, you're looking at everything at the individual user request level, right? And you can tell what one customer's experience is like versus another, right? And if you don't have that atomic level of granularity in your telemetry data, there's no way that you can make decisions like that. So with that, I do want to point out one of the things that I'm seeing in the chat is we have pasted some links for upcoming workshops. And yes, indeed, Pierre is hosting an advanced instrumentation workshop in August. I also believe that relevant to this body of work, there's an upcoming SLO workshop where we'll look at the mechanics of creating those and figuring out how to translate business requirements into what these definitions look like when they're implemented. So with that, I do want to take the time to let you know that there are a few additional events that you can join us for, both workshops and, again, the O'Reilly Observability Engineering Authors Cut series to keep diving into topics that we cover in the Observability and Engineering book. So thank you for joining us. That is all we have time for today. I want to thank Charity, Liz, and Pierre for joining me in today's presentation. Remember that a link to watch this webinar on demand will be in your inbox soon. And please feel free to share that webinar link with anybody else that you think would benefit from today's content. So thank you for joining us. Have a happy week, everyone.